Welcome to another great episode here on IT Pro TV. I'm your host, Ronnie Wong, and today we're taking a look at PMP, Project Management Professional. We're actually going to take a little bit of time going into some different formulas. Today we're going to be hitting the idea of schedule performance and showing how we can also discover the idea of variance too. And who better help us than, well, Mr. Don Pezet himself. How's it going, Don?
It is going great, Ronnie. Ready to jump into the world of variance. And just as a refresher, when we set up our schedule, we do our whole project plan, right? All in the planning phase. You're coming up with how things should be. And then when the project actually starts rolling into execution, we're monitoring and we're gathering data back on where things are going. And what you're going to notice is that what happens in the real world is a little different than your plan. Well, hopefully it isn't. Hopefully they're identical and things are great. But sometimes you get ahead of schedule, sometimes you get behind schedule, sometimes you get over or under budget. These things happen. And our main goal is to track those and make sure they stay in control, that they don't go too far. But the further away you get from the plan, that's called variance, right? We're deviating from what we planned, and we need to be able to measure that, and we need to do it repeatedly throughout our project. That way we can create trends, so we can see if things are getting worse and worse and worse, or if they're getting better. We need to have an understanding of that. So calculating variance is really important, and in a project you're going to be doing this all the time. Now you probably have project management software doing it for you, but if you don't, well, you can do it by hand. On the exam, you have to do it by hand. So that's why it's important for us to look at that, see how it works, and make sure we have a good grasp on it. And that's what we're going to do right here, is look at calculating out schedule variance. All right, well, let's kick things off. I got a fancy little picture here just to kind of make sure we have a good handle on what variance is. Remember that we have a plan, which in my case is this blue line, and then we have what's actually happening, and I've got this red line. And if I'm measuring my schedule variance at every point on this graph, I can see that I'm right in line here, right in line, right in line. And once I get to this measuring instance right here, I start to see a little deviation. But it's small enough that I probably don't think about it, right? I'm like, that's a little bit off, but not a big deal. But by the time I get to the next measuring point here, now that variance is starting to grow. And by the time I get to the next one, it's getting really big. I'm really getting a significantly larger gap in between these lines, and that's my warning sign. That means I need to take action. I had a warning back here, but I didn't know if it was a fluke, if things were just going to curve back again, or if it was going to continue to get worse. And if it continues to get worse, we need to correct it. We correct it, we bring things back in line, and we get ourselves back. Now, I'm showing the red line going up. The red line could be going down. It could be doing an S-curve. You could be all over the place with these things, right? That happens just as often as anything else. So, for example, I might have something a little more skewed like this, especially if we've made project corrections, right? So I could have it where maybe in the beginning I got off to a slow start. And so I started making some phone calls and saying, what the heck is going on down there? And notice how the variation kind of stabilizes right here. It doesn't get any worse, but it doesn't get any better, right? We've identified the problem and we stopped it, and now we start correcting it and we get back in line. But maybe we overcorrect. I used some of my reserves to bring in some extra staff, and I still have that extra staff hanging about, and now I'm starting to go the opposite way, where I'm going over budget or something of that nature, and I've got to bring that back in line. And so you may see your variance go like this, where it's constantly getting bigger and smaller over time. That's just how projects go. But the point is, by the end of the project, we need to be as close to that point as possible, that we have everything right where it's supposed to be. So in order to do that, we need to be taking measurements on a regular basis to make sure we can spot when this is happening. All right. Now, in another episode, we talked about planned value and earned value and how those work for calculating out kind of where we're at right now. Those are still important concepts for us here in scheduling, because when we talk about schedule variance, what's the formula? Well, the formula for schedule variance is one of the easier ones. Schedule variance equals earned value minus planned value. And so what does that mean? It means I need to know my earned value and I need to know my planned value. And if I don't know those values, then I can't figure out my schedule variance. So when you're on the exam and you go to fill out get to a question and it's asking about schedule variance, you actually could have a really hard question. You could have one that's going to require a lot of work. All right, but let's just kind of focus in on the individual pieces here. So schedule variance. How far am I deviating from my current schedule? And the result of this formula is going to be one of three things. It's going to either be a positive number, a negative number, or zero. All right. If it's a positive number, then we're ahead of schedule. More work has gotten done than what we anticipated. That may be good or bad. right? If it's a 0, we're right on schedule. Things are perfect. And if it's less than 0, if it's a negative number, then we're behind schedule. Now we've got a problem, okay? So those are the 3 possible outcomes of this formula. But all 3 of them require us to know our earned value and our planned value, because that's really what we're comparing at the end of the day, is the variance between those 2. So when we look at this formula, I know I need that information. Let's take a look at an example question and see how that pans out, right? This is one of the most straightforward types of questions you'll get on the exam, because they feed us exactly the data we need. It says, we've received a status report for activity 7.9. It's dated July 23rd. The report indicates an earned value of $3,000. According to the project plan, the value should be $3,500. What is your schedule variance? All right. This question is straightforward because they give me my plan value and they give me my earned value, and all I have to do is run it through a formula. All I have to do is take my earned value and subtract my plan value. Now, if those 2 are equal, I'll get a 0, right? Because a number minus the same number is always 0, and I have no variance. I'm right on schedule. If the numbers are different, though, that's where things start to get a little screwy. And I have to be really careful, because I could mix this up. If I do plan value minus earned value instead, then where I normally might get a negative number, I might now get a positive number, or vice versa. And so instead of thinking I'm behind schedule, I actually think I'm ahead of schedule. So when you memorize the formula, the order is really important. So when I fill this out, I need to say that my schedule variance is my earned value. So we've earned $3,000, right? That's how much we've kind of paid out so far. And I need to subtract my plan, and my plan is $3,500, all right? And if I work that out, I end up with a negative $500, right? And if you deal with accountants, they'll write it like that, right? So in parentheses, you might just say negative $500. If I had gotten these backwards, if I had said plan value minus earned value, I would have ended up with a positive $500, right? A positive $500 means I'm ahead. I've done more work than I thought I would at this point. A negative number means I'm behind. I've done less work. They're both a problem, right? Never assume that being ahead is a good thing. There's usually a reason why you're ahead, and it's something you didn't plan for, and that's bad, right? If it's something you planned for, you would have already done a change ticket and already updated your numbers, and your variance would be 0, right? So anytime you see variance, it's not a good thing. It's something that you need to find out the root cause of and either stop or capitalize on, right? You know, with risks, you can always jump in and really take advantage or exploit the risk to make it even better, and it gets just better and better and better. But either way, you need to be aware. So here I see a negative 500 though, and that means, hey, I should have gotten $500 more worth of work done by this point. Why not? Why hasn't that happened? And I can go in the field and find out. Maybe I was supposed to have 10 contractors on the job site, and 1 called in sick, and I only had 9. And since only 9 were there, I didn't have to pay for the 10th one. But less work got done because there were only 9 instead of 10, right? That's a problem. Now we got to make that up. So maybe the next day, instead of 10, I need 11 people to make up for the 1 I was short yesterday to even things back up. I need to be aware of that, right? But calculating that variance, really easy here, okay? However, on the exam, you might get one question like this, but normally it's going to be a little harder than that, right? Schedule variance is kind of an easy one to calculate, so they normally like to throw a little wrench in there. Here they very specifically gave me my earned value and my plan value, right? So I've got those. They didn't call it plan value here, but I know that's what it is because they tell me according to the project plan, blah, 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 right? So I know that's my plan value. But what if they had put the question like this? Work breakdown structure task 3.1.1 has spent $4,000 and is 25% complete. The project plan shows that $4,000 is correct, but the task should be 50% complete. What is the schedule variance? Okay, well, what is my earned value and what is my planned value? We actually don't know. They give us how much has been spent and how much is complete. They haven't actually factored those together yet. Remember that earned value is your planned value times the work complete. And so I've got my plan value up here, $4,000, and my work complete of 50%, but I have to factor that in, all right? And I know that my plan value is my budget at completion, which I actually don't know. We'll have to extrapolate that ourselves. And then multiply that by what I expect the work to be complete at that point. So looking at this, I have a little bit more math to do. I'm going to have to calculate earned value, and I'm going to have to calculate planned value. And then I can measure the difference to get my schedule value. So we end up with something a little more complex. Here, my schedule value is going to equal, or my schedule variance is going to equal, I need my earned value first, right? And earned value is my planned value times my percent complete, right? And then I need to subtract my planned value. And my planned value is my budget at completion times percent complete, which would really be 100% if it were the end. But in this case, we're doing at this particular point in time, so we'll use that information. So now this formula becomes a lot more complex. In fact, let me just, I'm going to have to, complex enough that I've got to shrink my font so this will all fit. There we go. Okay, so now what was a simple formula becomes a little more complex, right? But it's still not that bad because they did give me the information I need, right? So SV equals my plan value, which is $4,000, right, times, and here I'm talking about my earned value, so it's what I've actually done, which is only 25%. And then I need to subtract from that my planned value of budget at completion, which at this particular stage is $4,000. I don't actually know what the budget is for the full task, but I'm wanting to calculate at this point in time, so I can use this number that they provided me, $4,000, and multiply that by 50%. We're supposed to be 50% done. Okay. And now when we take that and run it, I'm actually going to need a little more room in this square. There we go. Now when we run all that, we get SV equals 4,000 times 25% is a whopping $1,000. And we're going to subtract 4,000 times 50%, which is a whopping $2,000, which equals a loss of $1,000, right? So our variance right here ends up being $1,000, okay? So I had to do a little extra work on this one. I had to calculate my earned value, I had to calculate my planned value, and then I had to subtract those out to find that variation, and then I got it, right? It wasn't that hard, but I actually needed to know 3 formulas to solve one problem. I had to know the earned value formula, the planned value formula, and the schedule variance formula, and then applied each one to get the data. That is not uncommon on the exam. You will see that happen where you've got to use all of your formulas. And so to help with this is one of the little pieces of advice that I always give people is when you go in to take the exam, right at the very beginning of the exam, you sit down, the exam starts, and you've got these scratch paper, pieces of notebook paper that are blank. Well, if you've got formulas memorized, just write them down real quick. It only takes a second. It doesn't take long to write the formulas down. And that way when you get to questions like these, you're not racking your brain trying to come up with them. You just look over and see the formulas and you just run through them and it's no big deal. And I assembled this to write it out like this, but I didn't have to do that. You can do a lot of this in your head. The exam will typically use numbers that are easy to do in your head because they don't give you a calculator, right? So when you talk about 25% of $4,000 or 50% of $4,000, that's easy stuff to do. It's not like I need 17% of $273,412, right? Which would take forever. So it's not normally crazy like that. But the end result is that I now have my variance and I can go and find the answer on the exam that matches that, and I'm in business. And if I don't find an answer that matches that, then I probably have a formula wrong and I need to go back and revisit that. So, but that's how we can get that schedule variance. Just know that even though it's an easy formula, SV equals EV minus PV, that it can be made more complex if we have to calculate out our earned value and our planned value to find out what to feed into the schedule variance formula. All right, now, in real life land, schedule variance is not a very useful number, right? If your CEO comes to you and says, hey, what's the status on your project? How's it going so far? And you say, well, we're plus $1,000 or we're negative $1,000. What does that really mean to them? Okay, well, it can sound good or bad. It depends on the size of the project and so on. But project numbers like these can easily get skewed because it's not necessarily meaningful beyond project managers. And so typically when we go to represent these numbers to other people, we don't use schedule variance like this. Instead, we use our performance indexes, right? You got SPI and CPI, your schedule performance index and your cost performance index. And we're just talking about schedule in this episode, so I'm going to talk about SPI. Schedule performance index is really the same basic process. except instead of SV equals EV minus PV, it's SV equals EV divided by PV, okay? And the reason it does that, actually, do I have a slide for that? I do. Yeah, I'm talking about it. I got a slide for it. So the reason it does this is that SPI is far better for giving people numbers that are meaningful and making it where you can compare projects together, okay? So SPI equals EV divided by PV. If I'm on schedule, if everything's going great, my EV and my PV should be equal, and a number divided by itself is 1. So if I get an SPI of 1, that means I'm on schedule, things are going great, okay? If I get a number that's less than 1, I'm behind schedule. If it's a number that's greater than 1, I'm ahead of schedule. And the number really works out to be a percentage. And so if I get 1.2 as my result, then I'm 20% ahead of schedule. If I get 0.8 as my result, then I'm behind 20% on my schedule, right? So 1, that is on schedule, that's your baseline, and then anything above or below is that percentage that you are ahead or behind. And that's really handy, especially if you're like a PMO. If you're a project management office and you're measuring the performance of multiple projects in your portfolio, right? You might have a multi-million-dollar project and you might have a $25,000 project. And when you start looking at the schedule variance, the multi-million-dollar project is always going to look worse because the numbers are so much bigger, right? But when you turn them into percentages like this, now it's more in line. Now we can compare them more accurately and understand what we're dealing with, right? So let me show you an example of that. I've got a couple of different examples, actually. SPI here, just your base SPI. So they might throw on the exam a question that just gives you the data you need. You factor it into the formula. You know, we kind of saw that earlier in the show. So here they tell us you have received a status report for activity 7.9 dated July 23rd. So the status report is dated July 23rd. The report indicates an earned value of $3,000. According to the project plan, the value should be $3,500. What is your SPI? Right. We saw this same question earlier, except instead of asking for SPI, it was asking for our schedule variance, or SV. All right. So same thing here, except instead of asking for SV, they're asking for SPI, and all we have to do is use the alternate formula. Instead of EV minus PV, we do EV divided by PV. So for this one, we say that our SPI equals, and it's going to be our earned value, $3,000, and that's going to be divided by $3,500, okay? And then we need to figure out what that is, and in my head I don't know, but if we fire up a quick calculator, we can say 3,000 divided by 3,500 is 0.8571, so I'm going to round that to 0.86. 0.86. Okay, 0.86, that's my SPI, all right? And remember what we said, if it's a negative, not a negative, sorry, if it's below 1, then we're behind. And if it's above 1, then we're ahead. And in this case, I've got 0.86. I've got an earned value of $3,000. I was supposed to have earned $3,500. I already knew I was behind. I just didn't know how bad. Let's put it into perspective, right? And if you tell me I'm $500 behind, that doesn't necessarily mean anything. But I can look at this and I can see that, you know, 1 minus 0.86 would be 0.14 or 14%. I'm 14% behind. Okay, now how bad is that? Is that really bad? Not really. No, I'm just 14% behind. I can probably make that up. I probably have resources I can apply to really get that corrected. Versus if I was 70% behind. That's pretty bad. That's pretty bad, and we're definitely going to need to deal with that. This takes the size of the project out of the mix. And that's really handy, not in a one-off like this, and this might be useful for talking to a CEO, for communicating to people, right? But when we're comparing more than one project to each other, and the budgets vary widely, this becomes really, really handy, right? And that's my next example. Let me show you guys this one. So let's say that you work for a PMO, right? So you work in a project management office, and you're looking at your project portfolio. And so here it says, you've been brought in to salvage 4 projects at risk of failure. So there's 4 projects going on in this company. They're all at risk of failure. Which of the 4 projects is in the most need of attention, right? So which one is your highest risk, basically? They're all at risk. They're all behind. Which one's the worst? Well, when we look at this, it can be hard to tell. If I just look at variance, right? So here's project 1, 2, 3, and 4. Project 1 has a planned value of $84,000, Project 2, $25,500, Project 3, $25,000, and Project 4, $1.4 million. All right. Projects 2 and 3 are very close in budget, right? So they very closely match each other. One's $25,000, one's $25,500. And when I look at those earned values, I see a huge difference there. And so if you give me the earned value, and one of them is $500 and the other one is $17,000, it's pretty obvious which one's at greater risk, okay? Project 3 is at a greater risk than Project 2 because they have similar budgets. But when you skew the budgets, right? When I look at Project 3 and Project 4, Project 3 has a $17,000 variance. Project 4 has a $200,000 variance. That's more than all the other projects combined. And so I might look at that and say, shoot, I need to tackle Project 4 because its variance is actually bigger than the full budget of all 3 of the other projects. Number 4 is the highest risk. I need to focus on that one, okay? But that can be misleading because in the general scheme of things, $200,000 might not be a lot when you're talking about $1.4 million, all right? And that's where SPI really comes in, is that we can create a number that's far more reasonable, that's easier to compare between these different systems to figure out which one is actually the worse off, okay? So SPI lets us do that, and here we've got the earned value and planned value. We just have to calculate it for each of these 4 to find out which one actually has the true worst schedule variance, all right? So let's run through that. If we take our earned value and our planned value, I need to start with that 76,000 and divide it by 84,000. So if I take 76,000 and divide it by 84,000, I end up with 0.904. So we'll round that to 0.90. All right, so I'm just going to fill that in here, 0.90. All right, and then we'll kind of move down the line here and go to the next one, which is 25,500. So we need to do 25,000 divided by 25,500, and that's going to be 0.98. 0.98. And then we just keep going, and all I'm doing is earned value divided by planned value, right? I'm applying the formula that we've got right here. So next is, this one will be nice, 8,000 divided by 25,000, which is 0.32. That's pretty bad. And then our last one, which is going to be 1.2 million divided by 1.4 million. All right, and I'm going to round that to 0.86. Okay, so now when I start to look at these, it becomes pretty obvious who's the real high-risk project. Okay, when you're talking about 0.86, that's 14%. We're 14% behind where we need to be. All right. That's not an unsurmountable obstacle. That's something that can be overcome. We probably have reserves. Hopefully you don't have 14% reserves because that's a little on the high side for reserves. But that you've got things you can shift around, people that you can put in place, that you've got the resources available to try and overcome that. It's just 14%, right? It's bad. Don't get me wrong. That's bad, but it's not unsurmountable, right? 0.98. That's only 2%. 2%. Who cares? That's probably just normal operations right there. Something that should have happened on Monday happened on Tuesday. Next week, something that should have happened on Tuesday happens on Monday and it goes away, right? You might not even need to take action at 0.98. You can practically ignore that one. 0.90, 10%, that's not great. That's not something you want to brag about to the team, but it's not that bad either, right? 0.32 though, boy, that one's off the rails. That's a project that needs to be canceled. It would be really, really difficult to overcome being 68% behind. That's significant. We've got a $25,000 planned value at this point, and we're only at $8,000. Does it mean that it's impossible to recover this project? No. You could still overcome it, but it's so far behind that it is going to fail unless you take significant action. And what action is that going to be? Well, it could be putting in change tickets to just allow for a different completion date. Hey, we were planning on finishing January 1st. Let's go back to March 1st now. So you do a delayed rollout. Or you request more funds. Hey, I'm sorry, the project went over. Can we get some more funds associated with it and see if we can overcome that? Or you just get down there and kick some butts, right? Maybe there's work that's supposed to be getting done that's not getting done, and you get in there and correct it. You could salvage this project, but it needs to be your first priority, right? Granted, it's a lower amount of money than we're talking about in Project 4, but it's in far worse shape than the other one. And SPI really makes it where we can compare these guys where schedule variance is not easy to compare. Schedule variance is great for just looking at one project. But when you're comparing multiple projects, SPI, Schedule Performance Index, that's the one that really works out. And so on the exam, when they ask for an SPI, they might ask for it on a single project, but more commonly, it'll be something like this. Here's 4 projects, which is the one that's in the most risk, right? And you got to calculate the SPI to figure that out. And we just kind of run down the line. It's simple math. They could make it hard. Here they gave me the EV and PV. Maybe they don't give you that, right? And now you got to calculate those out too, so you got a little extra work that's going to be before you. But otherwise, you can kind of run through them, calculate it out, and now you've got your answer. All right. So Schedule Performance Index, definitely one of the more useful ones out there in the real world too.
Don, is there anything else we need to consider in terms of the Schedule Performance Index besides just calculating that out? I see where it actually is valuable when we compare it against other projects, but is there anything else that we need to worry about on that one?
As far as the schedule side, no, but keep in mind we haven't talked about cost yet, right? The budgetary side. We're going to do another episode where we'll take a look at cost and budget. The hard part on the exam is they're easy to confuse,
yeah.
right? The formulas are very, very similar. They use a lot of the same data. You end up with indexes that are effectively the same. It's really easy to confuse. So everything you just saw, that's pretty straightforward. There wasn't anything confusing there. When we talk about cost, there really won't be anything confusing there, but when you put the two together, that's when it starts getting a little messy. So make sure you take your time when you read the question. Make sure you understand exactly what they're asking for. Are they asking for the Schedule Performance Index or the Cost Performance Index? Are we calculating out our schedule variance or our cost variance? Make sure you're using the right ones and the right numbers, because sometimes they'll give you all the information for both. And then you've got to know which one it is that you're trying to work for. And it's all right there in the wording of the question. Just take your time and read it.
So remember that what we actually took a look at here is the idea of the schedule variance itself and the Schedule Performance Index too. And even those formulas are similar. The very fact that we're actually using subtraction in one and division in the other doesn't help. So you want to make sure that those are locked into your mind before you get ready for that exam as well. Thank you, Don, for showing us those examples to help us to get ready for the exam. Thank you for also joining us. This is a great place for us to end this episode. Signing off for IT Pro TV, I'm Ronnie Wong.
And I'm Don Pizzette.
And we'll see you next time.